Alrighty, I hope you were not too scared by the last video and that really very large problem. When you see radical equations that have indices greater than 2, you have powers that are higher than 2, you do not need to panic. As long as those powers match, you can apply the same moves here. So let's look here. If I've got the cubed root on both sides, I can do the cubed root here. Or I can do a cube, pardon me. I can do a cube to both sides, and the cube roots will cancel. I get z plus 5. It'll also cancel on both sides. Convenient. And then we go ahead and solve. 5 equals z minus 6. It looks like z is equal to 11. Quick check. 11 plus 5 is 16. The cubed root of 16 is 4. No, it's not. The cubed root of 16 is not a whole number. It's 2 root 2. On the other side, we have 2 times 11 is 22. 22 minus 6 is also 16. So we also get the cubed root of 16. And something does equal itself. So z equals 11 is good. Over here we got the fourth power. So we can take the fourth power to the fourth, the fourth root to the fourth power, and they would cancel again. We get a plus 8 is equal to 2a. It looks like a is equal to 8, and it does work. Check. Now, this is not to imply that the only higher powers are the ones that will have it on both sides, but this is just showing you that nothing changes. So here, if that was a cubed root and a cubed root, that problem would still be immense. If we were back up on this one, B here, and it was a fifth root instead of a square root, it would still does not exist, and therefore it would still have an extraneous solution. So don't be misled by the simplicity of these, but know that because it is in higher power, it doesn't change anything. This is very important to remember in math in general, is that not a lot of the rules change, but also when it comes to formulas. Formulas, remember from various past chapters, sorry, I couldn't think of the word there, from various past units, formulas operate the same way as a regular equation. The only difference is that it has more than one variable. Okay, so if we have these two problems here, we can see that both of these formulas involve a square root. However, they have more than one variable. Okay, so instead of solving for, really at the end of the day, all we can do is rearrange for this variable, but we're going to solve it in the same way that you would solve as if there were only one variable. So I'm going to go ahead and I'm going to kind of go over the C that they are interested in. This is the variable of interest. I'm going to treat everything besides this C as if it was just another number. Okay, I'm going to pretend that they are not variables. What would I do first? To get things away from that C, I'm going to go ahead and square both sides. Now, I don't know what z squared is, so I can't actually compute that on the other side, but I sure can write z squared. That's what I have now. And the square root is still going to cancel on this side. Now, c is in the bottom. Flashback to rationals. How do you get things out of the denominator? You multiply them. Even though this is the variable in question, I am more than welcome to move it. And I get those canceling. So now I have z squared times c is equal to L. You do not have to switch those. You're more than welcome to write c times z squared, but in the second version, again, kind of with that same I conversation, just a little easier to see that the z is the only thing being squared. Since they're both variables, there's no reason that you have to have the c in front. All right, it matters even less because now I'm going to move the z squared to the other side anyway via division, so that c is by itself. And here we have a formula. Cool. No idea what z, L, and c stand for. At this point, don't care. Whatever eventually we're going to use this for, I have done what they've asked. I've solved for c. So let's do it again. Here I've got f is equal to 1 over 2 pi square root of LC. This is actually the formula for a spring and its frequency, but maybe you don't know that. And that's okay, because the rules of math don't change based on what we're talking about. The sciences bend to math, not the other way around. Math does not bend to anybody. Math is very rigid that way. So let's solve for L. Again, just a little mental trick. If you go over, and maybe in a different color, the variable in question, it might be easier to see what you need to do first. For example, this L is stuck in a denominator. That sucks. I'm going to go ahead and multiply everything to the other side. 2 pi f square root of LC. And yes, capitalization matters. You cannot make that a lowercase l or lowercase c, and you cannot make that an uppercase f. It is equal to 1 now. Now I'm going to move back everything that is not what I want. So 2 pi f. I'm not going to move the square root c because it's a little stuck right now. You're like, Miss K, why did you move the 2 pi? You just moved it right back. If you saw that, great. You don't need to move the 2 pi. Sometimes people think very unilaterally. They think I must move everything from the denominator out. Then I will deal with it. And if that works for you, great. But if you see that the only thing you really need to move is the square root LC, that's fine too. You can totally do that. So now we've got square root LC is equal to 1 over 2 pi f. All right, focusing on the L now. How do I get rid of that root? Let's go ahead and square both sides. No different moves here. I'm not suddenly pulling out a trig function, right? Nothing has changed. I'm still using the rules of solving. We end up with no, we don't. We end up with LC is equal to, let's actually go ahead and square everything here. 1 over 4 pi squared f squared, just so it's a little prettier. And then lastly, we can divide by c. Don't panic when you see that double fraction. It just sneaks in the bottom. Squared f squared c. And I have solved for L. Again, maybe you don't know what L and C and F all stand for, but you've done what they asked. You've solved for L. All right, that's it for 8.6. I apologize. The next section also says 8.6. Yours will say 8.7, solving rational application problems. But hopefully this all made sense. If it didn't, please reach out to your teacher, and I will see you in the next section.